Hello, are you holding your mobile phone right now? Or using your laptop while relaxing from the refreshing air from your fan or aircon? Did you use appliances to entertain yourself or to quicken and make your housework easier? Of course, this is what we are doing nowadays. By just plugging our lifeless appliances and gadgets in the socket, and tada! Those things are not lifeless anymore, for they become energized and do their jobs to entertain us and make work easier and faster. But have you ever thought where that energy came from or what type of energy it is? If you are thinking it is electrical energy, yes, you're right. Electrical energy is the power an atom's charged particles have to cause an action or move an object, and it is generated into three major categories, which are fossil fuels, nuclear energy, and renewable energy sources. And for my lesson, I will going to discuss to you one of the energy for electricity generation, which is nuclear energy. Before we proceed, let me introduce myself. I am Kant Herbie Pasinag from second year section Ezekiel taking BSN major in science. Nuclear energy. Albert Einstein said, nuclear energy is a hell of a way to boil water. So for our learning objectives, at the completion of this topic, the student should be able to first, define nuclear energy. Second, differentiate the two methods of releasing nuclear energy. Third, identify the positive and negative effect of using nuclear energy. And last, argue about an issue talking nuclear energy. So, let's start. Nuclear energy. Nuclear energy is the energy in the nucleus or core of an atom. It can be used to create electricity, but it must first be released from the atom. And in our illustration, we can see the three subatomic particles of an atom: the electron for negative charge, proton for positive charge, and neutron for neutral charge. Then, the nucleus can be found in the center of an atom. So, here, this is our nucleus. Then how to release the energy from the nucleus? There are two methods in releasing nuclear energy. These are nuclear fission and nuclear fusion. So let's start with nuclear fission. Nuclear fission. Nuclear fission is the process of splitting a nucleus into two nuclei with smaller masses. Fission means to divide. Fission means to divide. Remember that fission has two S's, therefore it splits into two parts. Here, we have a large atom which splitted into smaller atoms or two numbers with smaller masses. Then, while nag-split siya, ang energy is na-release po. Only large nuclei with atomic number above 90 can undergo fission. Product of fission's reaction usually include 2 or 3 individual neutrons. The total mass of the product is somewhat less than the mass of uranium-235. Take note that uranium-235 is the fuel used to release the energy in nuclear fission. So here in our illustration, from low-speed neutron recapture sa uranium-235, then nuclear fission reaction occur, and the products are thermal energy, radioactive materials, and high-speed neutron, wherein kaning high-speed neutron mauna ni ang mag-continue sa series of reaction, which is called chain reaction. So what is chain reaction? A chain reaction is an ongoing series of fission reactions. Billions of reactions occur each second in a chain reaction. In our illustration, first, a neutron is about to hit the nucleus of uranium atom. Then after that, the uranium nucleus split or mauna ni ang ginatawag nato nga fission into several smaller atoms, releasing heat and several more neutrons. Then after that, the chain reaction begins. Those neutrons hit other nuclei, causing them to fission, and so on. So, di ba, the more reaction nga gimahitabo, the more heat ma-release gikan sa reaction. Then, kani nga heat, mauna ni ang gamiton sa process sa pag-generate sa electricity. On Earth, nuclear fission reaction take place in nuclear reactors. Which use controlled chain reaction to generate electricity. So, we have what we call nuclear reactor, which is mauni ang gamiton to control chain reaction and to prevent the danger nga pwede madala sa too much na chain reaction. Nuclear reactor and its components. So here we have the overview of nuclear reactor. So components are, first is fuel. As what I said gaina nga ang fuel nga gina-use in fission is the element uranium, specifically the uranium-235. Moderator nga usually water but maybe heavy water or graphite. Then control rods or blades nga of course metal nga conductor of heat. We have coolants, pressure vessels or tubes, steam generator nga magpatuyok sa turbines to generate electricity, and of course containment. In USA, na ay two types of reactor nga ginagamit. It is the boiling water reactor or BWR and the pressurized water reactor or the PWR. BWR or boiling water reactor. BWR heat water and produce steam directly inside the reactor vessel. Water is pumped up through the reactor core and heated by fission. Pipes then feed the steam directly to a turbine to produce electricity. The unused steam is then condensed back to water and reused in the heating process. While pressurized water reactor or PWR, this reactor pumps water into the reactor core under high pressure to prevent the water from boiling. The water in the core is heated by nuclear fission and then pumped into tubes inside a heat exchanger. Those tubes heat a separate water source to create steam. The steam then turns an electric generator to produce electricity. The core water cycles back to the reactor to be reheated and the process is repeated. So, ang kalahian lang niya is that ang PWR kay naa siya pressure tank to prevent the water to boil, while ang BWR is magboil jud ang water. And controlled chain reaction take place during explosion of an atomic bomb. So, other example ni siya of chain reaction, uncontrolled chain reaction, which is the explosion of atomic bomb. So, what is the fission products? The products of nuclear fission reaction are radioactive, but the energy released from this reaction is less harmful to the environment than use of fossil fuels. The products are intensely radioactive and must be treated and or stored. So that's all for nuclear fission. Then for other way to release nuclear energy is through nuclear fusion. So nuclear fusion. Nuclear fusion is the combining of two nuclei with low masses to form one nucleus of larger masses. Nuclear fusion reaction are also called thermonuclear reaction. So, di ba, ang nuclear fission is from larger atom, it's split it into several smaller atoms, while kaning nuclear fusion is opposite lang siya sa fission. From small atoms, gi-combine into large atoms, but ilang similarities is that naga-release sila og heat or energy. Fusion reaction exists in stars. Our sun is a good example of thermonuclear fusion or fusion reaction. It is almost impossible to create fusion reaction on Earth since they need temperature above 1 million degrees Celsius in order to take place. And based on my research, nuclear fission is under R&D phase or research and development phase. And based po sa news from Vox Media, the nuclear fusion experiment kay mag-start sa 2030 by the ITER or International Thermonuclear Experimental Reactor o NIF or National Ignition Facility, who's aiming to have nuclear fusion here in the Earth by the use of their different approaches. ITER involves using magnets to contain the plasma, while NIF involves confining the fusion fuel and compressing it in a tiny space with the aid of lasers. So nothing is impossible jud para sa mga scientists just to have a clean source of electricity para sa tanan. Nuclear fusion produces less nuclear waste than nuclear fission, and the materials are easier to obtain. Mas cleaner and cheap jud di ay ang nuclear fusion kay less lang ang waste nga ma-produce and the material are easy to obtain compared to nuclear fission. So ang materials nga needed in nuclear fusion is the deuterium, which can easily be extracted from seawater, and tritium, which can be produced by lithium nga widely distributed in earth crust. Then products of nuclear fusion are helium, neutron, and of course heat energy. That's for nuclear fusion. So let's go to the pros and cons of nuclear energy. Specifically, nuclear fission kay maupaman ang pwede. So pros and cons of nuclear power. So let's start with pros. First, nuclear energy is carbon-free electricity. For if we compare it to fossil fuel pump massive amount of carbon dioxide, which is the primary cause of global climate change, into the atmosphere. Nuclear energy plants do not produce carbon dioxide or any pollution during operation. Second is small land footprint. Compared to other common clean energy facilities, particularly wind and solar power, nuclear energy plants takes up for less physical space. According to Department of Energy, a typical nuclear facility producing 1,000 megawatts of electricity takes up about 1 square miles of space. Comparatively, a wind farm producing the same amount of energy takes 360 times more land area, and a large-scale solar farm uses 75 more space. That's 431 wind turbines or 3.125 million solar panels. Then third, high power output. Nuclear power plants produce high levels of energy compared to most power sources, especially renewables, which makes them a great provider of baseload electricity. Baseload electricity simply means the minimum level of energy demand on the grid over a span of time, say a week. Nuclear has the potential to be the high output baseload source, and we're headed the way since 1990. Nuclear power plants have generated 20% of US electricity. Additionally, nuclear is a prime candidate for replacing current baseload electricity sources that contribute significantly to air pollution, such as large coal plants. And last, for pros, is reliable energy source. Nuclear energy is a reliable renewable energy source based on its constant production and accessibility. Nuclear power plants produce at their maximum power output more often, 93% of the time, than any other energy source. And because of this round-the-clock stability, this makes nuclear energy an ideal source of reliable baseload electricity for the grid. But of course, naapod siya cons, which are first, is the uranium is non-renewable. Although nuclear energy is a clean source of power, it is technically not renewable. Currently, nuclear technology relies on uranium ore for fuel, which exists in limited amounts in the Earth crust. The longer we rely on nuclear power, and uranium ore in particular, the more depleted the Earth uranium resources will become, which will drive up the cost of extracting it as well as the negative environmental impacts from mining and processing the uranium. Second, high upfront cost. Operating a nuclear power plant is a relatively low-cost endeavor, but building it in the first place is very expensive. Nuclear reactors are complex devices that requires many levels of safety built around them, which drives up the cost of new nuclear plants. Then third, nuclear waste. Nuclear waste is radioactive, making it an environmental and health catastrophe waiting to happen. These reasons are exactly why governments spend tons of money to safely package up and dispose of used up nuclear fuel. At the end of the days, yes, nuclear waste is a dangerous byproduct of nuclear power plants, and it takes extreme care and advanced technology to handle it properly. And last, malfunction can be catastrophic. A nuclear meltdown occurs when the heat created by a nuclear reactor exceeds the amount of heat being transferred out by the cooling systems. This causes the system to exceed its melting point. If this happens, hot radioactive vapors can escape, which can cause nuclear plants to fully melt down and combust, while also releasing harmful radioactive materials into the environment. This is a worst-case scenario that is extremely unlikely, and nuclear plants are equipped with numerous safety measures to prevent meltdown from happening. So examples for this are the three significant accidents at nuclear power plants. First is the 3 Mile Island in USA in 1979, where the reactor was severely damaged but radiation was contained and there were no adverse health or environmental consequences. Second is Chernobyl in Ukraine in 1986, where the destruction of the reactor by steam explosion and fire killed 2 people initially plus further 28 from radiation poisoning within 3 months and had significant health and environmental consequences. And last, third, Fukushima Daiichi in Japan 2011, where 3 old reactors, together with a fourth, were written off after the effect of loss of cooling due to huge tsunami were inadequately contained. There were no deaths or serious injuries due to radioactivity, though about 19,500 people were killed by the tsunami. And here in the Philippines, we have the Bataan Nuclear Power Plant nga gibuild in the time of Ferdinand Marcos Sr. nga wala nagamit because of political issues and many more. So watch this video, and after watching, I will going to ask you.
Entering the Philippines' only nuclear power plant is like a step back in time. The Bataan Nuclear Power Plant was built in the 70s and was the first in Southeast Asia. But it never opened. It was mothballed, and past presidents were hesitant to recommission it because it was a reminder, they say, of the excesses of former President Ferdinand Marcos's regime. But the country's electricity prices are among the highest in Southeast Asia, partly because its dependence now on imported fossil fuels. That means the average Filipino family spends between 10 to 20% of their monthly income in electricity.
Philippines has for decades now been avoided as an investment destination in Southeast Asia because our electricity has either been too expensive or in short supply and unreliable.
Philippine President Rodrigo Duterte has ordered his officials to look into the possibility of including nuclear power into the country's energy mix and the possible revival of the Bataan nuclear power plant.
It tells the whole world we're ready for nuclear. BNPP has 3 sister plants that have been running for over 30 years. Exact same design. They are in Slovenia, in Brazil, and in South Korea. But what people forget is that no nuclear plant in the world operates without the blessings of the International Atomic Energy Agency, the watchdog.
It is quite clear that some parts of the nuclear power plant are aging. But regulators here tell us all it needs is a few years and an estimated $1.2 billion of commissioning, and it will be as good as brand new. But there are also those in government who say the Bataan nuclear power plant belongs to a bygone era.
There's already a big pushback on nuclear technology itself. Now you're going to jumpstart a plant which is old and embroiled in controversy. We don't want to start our nuclear program in the wrong foot. You want to start it in the right foot.
Environmental activists also believe that the government should focus on producing clean energy instead. like wind and solar. But whether Bataan will be recommissioned by President Rodrigo Duterte or not, one thing they say is for sure. The energy crisis in the country is a social justice issue, and one that may worsen if there is no investment in the country's energy system. Jamela Alindogan, Al Jazeera, Bataan Province, Northern.
So here is my question. If you are the current president of the Philippines, do you want the Bataan nuclear power plant to operate? Why? Then, don't forget to use what you have learned in our discussion and apply the 3 social science principles of sustainability, the politics, economics, and ethics. And to summarize my report, let's watch this music video by Mark Rosengarten. Thank you and God bless us all.
Einstein postulated in reactions nuclear, the laws of conservation had boundaries that blur. Energy was given off more than was its share. The equation that he got, E equals MC squared. That's right, that's what I got. Fission, fission, split apart, lots of power at its heart. If you shoot a neutron that's moving somewhat slow, uranium-235 can pick it up and blow. It splits the nucleus into 2 smaller nuclei and give off 3 more neutrons. Just watch those suckers fly. If those neutrons hit more U-235s, ouch! Once a moderator has slowed them down to size, then a chain reaction starts. Things will get real hot. Ow! Put in the control rods if you want that knot. The heat that's given off is used in power plants that actually makes most of the electricity in France. It powers aircraft carriers and also submarines. If not for radioactive waste, it would be the stuff of dreams. I must be dreaming. Fission's when you split apart an atom of great size. Hit it hard and get a bunch of smaller nuclei. Fusion's what you get when 2 small nuclei combine. Both give off lots of energy, according to Einstein. That's what I said! Fusion, fusion, like the sun. Energy for everyone. Hydrogen has isotopes like deuterium. When they come together, they can make a helium. That's right. The process does create lots of energy from mass. But to make this sucker work, it must be hotter than a gas. Ow, ow, ooh, ooh, ha, ha, ha. Nuclei have protons and are thus positive charge, so they repel each other, especially when they're large. Hey, watch it! So to get the nuclei to come together and have fun, you will need high temperature and pressure like the sun. The temperature's so hot that it's in the plasma state. Everything plasma touches in an instant deflagrates. You need to keep it bottled inside strong magnetic fields, so more energy is used than we can get in useful yields. That stinks! Fission's when you split apart an atom of great size. Whoa! hit it hard and get a bunch of smaller nuclei. Fusion's what you get when two small nuclei combine. And both will be the future for the power of mankind. And both will be the future for the power of mankind.